Let's get right into it. Number 10. Ball lightning. You're sitting at home during a thunderstorm when suddenly a glowing ball of light floats through your wall. These mysterious orbs show up during thunderstorms, but they don't act like normal lightning at all. Ball lightning stays way too long, floats around your house, and passes through walls just for fun. These glowing orbs can be as small as a ping-pong ball or as big as a beach ball. They can float through solid walls, hover in midair, and sometimes even explode. One pilot reported a ball of lightning that followed his plane for several minutes, like some kind of atmospheric stalker. Scientists have tried to explain it with all sorts of theories. Some say it's plasma, superheated gas that somehow stays together in a ball. Others think it might be a hallucination caused by electromagnetic fields messing with our brains. In 2014, scientists in China actually caught one on video by complete accident. They were filming a regular lightning strike when ball lightning showed up, like a photobombing ghost. The footage showed it was full of silicon, iron, and calcium, basically the same stuff that's in soil. So maybe when lightning hits the ground, it vaporizes these elements into a glowing ball of weirdness. But that still doesn't explain how it can pass through walls, or why it seems to have a mind of its own. It's like nature decided to create its own version of a haunted house special effect, just to mess with physicists. Number 9. Creating stars with sound. Scientists accidentally created tiny stars in a lab using nothing but sound and water. You take a glass of water, add a tiny bubble, and blast it with sound waves. The bubble collapses so violently that it creates a flash of light and temperatures hotter than the surface of the sun. We're talking about turning sound into star-level heat in a glass of water. This shouldn't be possible. Sound waves don't have nearly enough energy to create light. It's like trying to heat up your coffee by screaming at it. The math just doesn't add up. But somehow, this tiny bubble is taking weak sound waves and turning them into temperatures reaching over 10,000 degrees. That's like taking a whisper and turning it into a supernova. The bubbles compress so quickly that the gas inside gets squeezed into a space smaller than a human hair. The collapse happens in less than a billionth of a second. It's like each bubble becomes a tiny star for a fraction of a second, then dies. The crazy part is we still don't fully understand how this works. The amount of energy concentrated in that tiny space seems to violate what we know about physics. Next time you're drinking a glass of water, remember, with the right sound waves, you could be holding thousands of microscopic stars. Number 8. The Casimir Effect. Imagine two metal plates floating in empty space. Nothing between them. Pure vacuum. Bring these plates really close together. A few atoms apart, they start getting pulled together. But there's literally nothing pushing or pulling them. It's like two people in a completely empty room being pushed together by invisible hands. This is the Casimir Effect. It breaks everything we thought we knew about empty space. We used to think empty space was just that. Empty. But quantum physics says empty space is full of invisible energy fluctuations, an invisible ocean of particles popping in and out of existence, too fast to see. When you put those two plates really close together, something bizarre happens. The space between the plates is so tiny that some of these energy waves just can't fit. Outside the plates, all the waves can exist freely. You end up with more waves pushing from the outside than from the inside, a push that comes out of thin air. Scientists have measured this force. It's real. A force from absolutely nothing. This effect is so powerful engineers worry about it when building tiny machines. Imagine building a microscopic robot and having to account for the force of nothingness. Number 7. Breaking the cosmic speed limit. Einstein said nothing can move faster than light, and he was right. But these galaxies found a loophole. Einstein's speed limit only applies to things moving through space, but space itself can move. Imagine you're drawing two dots on a balloon. The dots aren't moving on the surface, but as you blow up the balloon, they get further apart. The universe is pulling the same stunt on a cosmic scale. Space itself is stretching like that balloon. There's no speed limit on how fast space can stretch. Scientists have found galaxies that are moving away from us faster than the speed of light. They're not actually breaking any laws of physics. They're just hanging in space while the space between us and them stretches like cosmic silly putty. Imagine you're on a cosmic treadmill that's going faster than you can run. No matter how fast you run forward, you're still moving backward. That's what's happening to the light from these galaxies. The space between us is stretching so fast that their light will never reach us. These galaxies are literally disappearing from our view, trapped behind what we call the cosmic horizon. It's like they're being pushed over a waterfall, but instead of water, it's space itself doing the pushing. Billions of years from now, future astronomers might look up at the night sky and think we're alone in the universe because they can't see anything else out there. Number 6. The Hubble Tension. Imagine you're measuring the height of a building. You use a tape measure from the ground, and it says 100 feet. Then you measure it from a helicopter, and it says 150 feet. Both measurements are correct. Both used perfect tools, but somehow you're getting two completely different numbers. That's exactly what's happening with the universe's expansion rate. We have two ways to measure how fast the universe is expanding. First method, we look at the cosmic microwave background, the leftover heat from the Big Bang. It's like looking at the universe's baby photos. Second method, we look at nearby galaxies and special stars called Cepheid variables. It's like measuring the universe's current driver's license photo. These two measurements don't match at all. The nearby measurements say the universe is expanding about 73 kilometers per second per megaparsec. The ancient light says it's more like 67. In cosmic terms, this is like finding out your identical twin is actually a foot taller than you. It shouldn't be possible. Scientists have checked and rechecked their math so many times they're probably seeing numbers in their sleep. Some think this might mean dark energy is getting stronger over time. Others think we might need to completely rewrite the laws of physics. The more precisely we measure it, the more obvious this difference becomes. Number 5. Spooky action at a distance. Picture two identical twins, one on Mars, one on Earth. Whenever one puts on a red shirt, the other instantly does too. No phone call, no delay. Instantly. That's quantum entanglement. Except it's particles doing synchronized quantum dance moves across space. Einstein called it spooky action at a distance. He hated the idea, but the universe doesn't care what Einstein thinks. Scientists have proven that when you mess with one entangled particle, its partner instantly responds, even if they're millions of light years apart. It's like they're connected by some cosmic group chat that works faster than light itself. Nothing can go faster than light. That's the rule. But here's the catch. You can't actually use entanglement to send messages. It's like two coins that always land on opposite sides. Flip one, it lands heads. You instantly know the other is tails. You just can't choose which side your coin lands on. Nobody actually knows how this works. We can prove it happens. We can measure it. We can build stuff with it. Ask a physicist to explain exactly how one particle knows what its partner is doing across the galaxy, and they'll mumble about quantum mechanics and wave functions. Or just shrug. Quantum entanglement is proof that reality is way weirder than we thought. Number 4. The identity crisis of matter. Imagine you're at a party, and there's this person who acts completely different depending on who's watching. When no one's looking, they're everywhere at once, dancing through multiple rooms simultaneously. But the moment someone tries to spot them, they're suddenly in just one specific spot, acting totally normal. That's basically what particles do in our universe. This behavior is called wave-particle duality. Scientists discovered this with the double-slit experiment. They shot tiny particles, like electrons, through two slits in a wall. If these were like tiny bullets, you'd expect two bands of hits on the wall behind. That's not what happened. Instead, they got a stripy pattern that only waves should make. Then scientists put detectors at the slits to see which hole each particle went through. The pattern disappeared. The particles started acting like normal particles again, like they knew they were being watched. These particles don't exist in one place until you look at them. They exist in all possible places at once, as a wave of possibilities. Scientists call this a probability wave. It's like having a friend who, until you call them, is simultaneously at home, at work, and on vacation. The moment you try to find them, they collapse into just one location. This is shattering our entire understanding of reality. The very act of observing something changes how it behaves. Number 3. Quantum tunneling. Imagine throwing tennis balls at a brick wall. They should bounce back. But in the quantum world, sometimes these balls pop up on the other side. That's quantum tunneling. It's like running at a wall with only enough energy to get halfway up. In normal physics, you'd bounce off. In the quantum world, there's a tiny chance you'd appear on the other side. This actually happens all the time. The sun wouldn't work without it. Particles in the sun's core don't have enough energy to fuse together, but they tunnel through anyway. And that's what keeps us alive. Your body is doing it right now, every second. Particles are quantum tunneling inside your cells. Modern computer chips? Quantum tunneling. Those flash drives you use? Quantum tunneling. The larger something is, the less likely it is to tunnel. Electrons do it all the time, but you won't be walking through walls anytime soon. But there's a tiny, astronomically small chance all your particles could tunnel through a wall at the same time. Scientists calculated if you ran into a wall once per second, you might eventually go through it. You just need to keep trying for longer than the universe has existed. Number 2. The black hole information paradox. Throw a book into a fire. The book burns up, but technically all the information about that book still exists. It's just scattered in the smoke, ash, and heat. Black holes play by different rules. When something falls into a black hole, according to Einstein, that information is gone forever. Not scattered, not transformed, just gone. This is where physics starts having an existential crisis. Quantum mechanics has one rule it's really strict about. Information can never be destroyed. Everything that happens leaves a trace. But when Stephen Hawking discovered that black holes actually evaporate over time, physicists lost their minds. Because if a black hole eventually disappears, all the stuff that fell in disappears with it. All that information is just gone. It's like having a cosmic paper shredder that doesn't just cut up documents, it makes them vanish from reality itself. Quantum mechanics is standing there saying, that's impossible, while general relativity is like, watch me. If information can truly be destroyed, then cause and effect break down. Some scientists think they've found a solution. They say the information might be encoded in subtle patterns in the Hawking radiation. Others think the information might be stored in microscopic wrinkles of space-time near the black hole's edge, like nature's ultimate hard drive. Number 1. The universe's anti-gravity. Imagine throwing a ball up in the air. Gravity should pull it back down, but instead it starts going faster and faster until it disappears into space. That's what our universe is doing. It's not just expanding, it's speeding up as it expands. And we have no idea what's causing this. Scientists call it dark energy, because that sounds cooler than... We have absolutely no clue what this is. This mysterious force makes up about 68% of everything in the universe. Most of what exists is something we can't see, can't touch, and completely violates our understanding of physics. It's like finding out that 68% of your house is made of invisible furniture that's somehow pushing your walls outward. This force is literally stronger than gravity. Gravity, the same force that keeps planets in orbit, is getting beaten by something we can't even detect. It acts like anti-gravity, pushing everything apart. And the further apart things get, the stronger dark energy becomes. If dark energy keeps getting stronger, it might tear apart galaxies, solar systems, planets, even atoms. Scientists call this the Big Rip. Everything in the universe ripped apart by this mysterious anti-gravity force. It won't happen for at least another few billion years, but it's a reminder that the most powerful force in the universe is one we don't understand at all. That's all for today. I'll be making similar videos in the future. Subscribe to see them.